Recitation problem 2. The angular speed of a rotor in the centrifuge increases from 420 to 1420 radians per second in a time t equals to 5 seconds. Two questions. Obtain the angle through which the rotor turns, and B, what is the magnitude of the angular acceleration? Alright, let's write down the information that we have here first. Omega 0, the initial angular velocity is given to us to equal 420 radians per second. We also know the final angular velocity, which is 1420 radians per second. We have the time that was taken for the rotor to go from 420 to 1420, which is 5 seconds. Based on the information that is given to us, the best kinematics tool that can be used to solve for the angle is the following one. Theta minus theta 0 equals 1/2 omega plus omega 0 times the time t. I'm gonna start my theta from 0, therefore this one is dropped. What's left? Theta equals 1/2 omega final plus omega initial times the time. We know the time, we know omega initial, omega final. Solve for the theta, we obtain theta equals 4.60 times 10 to the third radians. This is part A that we have solved for. Now let's move on and solve for part B. The question is, what is the magnitude of the angular acceleration alpha? Since we know the initial omega and the final omega and also the time, the best relationship is omega equals omega 0 plus alpha t. Very simple and straightforward. You can isolate the alpha to be omega minus omega 0 divided by the time. Solve for the alpha, you obtain 2.00 10 to the second radians per second squared.